Welcome to Electrobox. I'm Jacob. Some time ago my best friend made me this custom front plate for my Xbox controller. In this video I'm taking the controller one step further by adding wireless charging. The goal is simple. Whenever I need the controller, it should already be charged and ready to use. Let's see whether I can make it work. Before modifying the controller, we first need to look at its power requirements. Normally the Xbox controller uses two AA batteries connected in series. With approximately 1.5 volts per battery, the controller receives around 3 volts. A rechargeable single-cell lithium battery, however, has a nominal voltage of 3.7 volts and can reach up to 4.2 volts when fully charged. Connecting it directly to the controller would therefore supply too much voltage. To solve this problem, I need a DC-DC converter that provides a stable 3 volt output throughout the usable battery voltage range. However, voltage conversion alone is not enough. The converter should also include undervoltage protection and shut down when the battery voltage falls below approximately 3 volts. Without this cutoff, the controller could continue discharging the lithium battery too deeply, which could permanently damage the cell. Alternatively, this protection can be provided by a protected battery or a separate battery protection circuit. For charging, I will use a pre-built wireless charging receiver that already includes the receiver coil and the required charging electronics. If you are interested in learning more about the electronics behind the charging circuit and DC-DC converters, let me know in the comments. If there are enough questions, I can make separate learning videos about these topics. For this project I will use a wireless charging receiver with an integrated coil and charging electronics, a rechargeable lithium battery, DC-DC converters for generating a stable 3 volt output, the Xbox controller, wires, connectors, double-sided tape and soldering equipment. Before installing anything inside the controller, I first tested the charging circuit separately. I soldered the battery to the battery terminals of the wireless charging receiver and placed the coil on a wireless charging pad. The battery started charging, which confirmed that the receiver and charging circuit were working correctly. I'm currently using a standard wireless charging pad, but I may build a custom charging stand specifically for this controller in the future. If you would like to see that project, leave me a comment. After confirming that the battery could be charged, I started working on the power conversion circuit. This is where I run into my first problem. The buck converters I had available require an input voltage of at least 4.5 volts. A single lithium battery only provides between approximately 3 and 4.2 volts, so the buck converter could not be connected directly to it. For this prototype, I therefore used a small boost converter to increase the battery voltage to 5 volts. I then use a buck converter to reduce the voltage back down to a stable 3 volts for the controller. Converting the voltage twice is not very efficient, so this is not the ideal long-term solution. However, it works well enough to test the concept. A more efficient final version would use a suitable buck boost converter that can generate 3 volts directly from the battery. Next, I connected the complete circuit and measured the voltage at each stage. The battery voltage was approximately 3.9 volts. The input of the boost converter was also 3.9 volts, while its output was 5 volts. After the buck converter, I measured a stable output voltage of 3 volts. Everything was working as expected, so I could start modifying the controller. At this point, I temporarily disconnected the circuit because I didn't yet know the exact position of the components or the required cable length. To create enough room for the battery and electronics, I needed to modify the controller's battery compartment. First I removed the side grips using a plastic opening tool. Next I removed the sticker inside the battery compartment to access the hidden screw. After removing the screw and the 4 remaining screws, the controller housing could be carefully separated. I used a small rotary tool saw to cut away the internal section of the battery compartment. I removed only as much material as necessary and made sure to keep the mounting points for the battery cover. This allows the original cover to remain securely attached after the modification. Once the cutting was finished, I tested whether the battery and electronic components could fit inside the controller. Fortunately, everything fitted as planned. I added pin headers to the wireless charging receiver board and attached a removable connector to the battery wiring. This allows me to separate the battery cover from the controller without pulling or damaging the solder joints. The charging coil can therefore remain attached to the battery cover while still being easy to disconnect during maintenance. Next, I soldered 2 wires to the controller's battery power terminals. I connected these wires to the 3V output of the DC-DC conversion circuit, making sure that the polarity was correct. Before installing the electronics permanently, I performed another voltage measurement to confirm that the controller would receive the correct supply voltage. I used double-sided tape to secure the converter boards inside the controller. After positioning the boards, I carefully checked that no wires were being pinched and that the controller housing could still close properly. Next, I placed the battery inside the modified compartment and connected its output to the converter input. The charging receiver and coil were then connected to the battery. After one final function test, I reassembled the controller and tightened all 5 screws. Now it's time for the final test. The controller powers on normally and connects to the Xbox without any problems. When I place it on the wireless charging pad, the receiver activates and the battery begins charging. Everything seems to work exactly as planned. And this is how I modified my controller to support wireless charging. You can find projects like this and additional information on my website electrobox.ch. If you enjoyed this video, leave a like and subscribe to my channel. Thank you for watching and see you next time.